Hello, it's me, Daniel and Stephanie. All right.
Perfect. So we're going to go and start with question 1.
Oh gosh.
Okay. So for question 1, we're supposing an individual has heterozygous for the following inversion. So if we look at the problem, right there, this big long chromosome is the normal chromosome, and then we have the inversion chromosome. And so what we're going to do is we should start out by writing these out so that the and the T match, because we're doing a crossover between the S and the T. So we have capital L. WX. And so the cross is happening between the S and the T. So this one we're going to kind of write backwards. So we have little x, W, R, S, T, U, V, P, Q, O. And so what's going to happen is that this and this are going to switch places. So we'll rewrite it as little x, W, R, S, big T, big U, U, V, W, X. And then we're going to rewrite this one as well. So big L, M, N, dot, O, P, Q, R, S, little t, little u, little v, little p, little q, o, little n, little m, little o. And so what we can see that happens is that one of them has no centromeres, the other one has 2 centromeres. And that is question number 1.
All right. So for question 2. Okay, so for question 2, A is meiosis 2 and mitosis, B is paracentric inversion, C is Turner's Turner syndrome and familial Down syndrome, D is liver, and E is the word that she knows how to say. Yeah, and type A hemophilia. F, we weren't sure about this one. I said it was production of duplications and deletions, because that's what led to the variations among the alleles that control hemoglobin, or rather globin. Yeah, where was it? Oh yeah, and then G is alternate, and that leads us to number 3.
Perfect. So for number 3, for A, we're going to talk about the number of chromosomes that will be found in humans for the following conditions. So A, for the first bullet point, we have Turner syndrome, which will give us 45 chromosomes. Jacob syndrome will give us 47 chromosomes. Clichy-Schatz syndrome will give us 46 chromosomes. Familial Down syndrome gives us 46 chromosomes. And then type A hemophilia will give us 46 chromosomes. So that'll bring us to B. Which of the following terms is not associated with share Charcot-Marie tooth disease, type 1A. And so we marked all of them are not associated except for duplication. So it'll bring us to C. Which of the following terms are associated with Kiefer syndrome? And so the ones that are associated with that are aneuploid, trimosy, non-disjunction, and then duplication. And so for D, which of the following terms are associated with type A hemophilia? And we said that none of them were because none of them are involved with, let me look up the word, with inversions. And so, yeah, that's for part D. So we'll answer question 4.
All right. So for question 4, okay. So for question 4, we have something similar to question 1, except instead of having so we have 2 chromosomes and one of them got reversed. Well, actually, let me say it differently. So what we have is we have 2 homologous chromosomes. We have D, E, F, G, H, I. We have J, K, L. And then we have another copy of this one. It's homologous pair. And then we also have M, N, O, P, Q. Sorry, and also brought a Q, Q, R, S, and T. And then this one also has its homologous pair. Now what's happened to the 2 homologous pairs of these 2 is they each have performed an inversion. So we end up, not an inversion, it's a reciprocal translocation. So a piece of this one went into this one, and a piece of this one went into this one, and we ended up with.
That'd
be very nice, thank you. E, F.
D, E, F, P, the star, Q, R, S, T. And so the next one is M, N, O, G, H, star, I, J, K, L. The next one is D, E.
That's all done.
Oh,
thank you.
Sorry.
Okay, so yeah, so all this came from this one, and all this came from this one. So they switched. That's what a reciprocal translocation is. And then it says it wants you to diagram the synapsis of these chromosomes in prophase 1. So if we remember, synapsis is where the chromosomes line up. So what will happen is this chromosome will duplicate itself. Each one of these 4 chromosomes will duplicate itself to make 2 sister chromatids. And then this one will line up with its homologous pair. Each of these will line up with their homologous pair. Now, the trouble is, it doesn't tell us which ones are the homologous pair. We don't know if this one is homologous to this one or this one. So what I did was I said, since this one and this one have all this, in common, these 2 must be reciprocal. And then since these two have all this, since these two have all this in common, they must be reciprocal. So this is reciprocal to this. This is reciprocal to this. Okay, so what will happen is these two will line up side by side, and these two will line up side by side in synapses in prophase 1. And that's where crossing over can occur. But it doesn't tell us that crossing over happens, so we're not going to try to write it out or calculate it because we don't know how. So we won't worry about that right now. And part B, it says, identify the allele composition of the gametes produced by alternate segregation. Okay, so alternate segregation is where the normal chromosome, this one, will match up with the normal chromosome, this one. So these two will go together, and they will go into one gamete. And then these two, the two mutants, will go into another gamete. So there'll be 2 with these and 2 with these, an alternate. And C is identify the allele composition of the gametes produced by adjacent one segregation. Okay, this is where it gets a little more complicated. Okay, so in adjacent one, what happens is tell us if I can see it. Hang on 1 second. Okay, so in adjacent one segregation, no, this is bad, I'm not using this one. This one makes a lot more. Okay, so in adjacent two segregation, what happens is, so since I said that these two are homologous and these two are homologous, what happened is this normal one will match up with the mutant from the other pair. And then this normal one will match up with the mutant from the other pair. So that's adjacent one. That's what will happen there. And then lastly, we have part D, which says identify the allele composition of the gametes produced by adjacent two segregation. Okay, so in adjacent two, since I said that these two and these two are homologous, what happened is you'll end up with a gamete that is these two chromosomes. So instead of chromosome 1 and 2 separating and going into the 4 gametes, the gametes will get both copies of this chromosome. So they'll have 2 copies of chromosome 1, and they'll have 2 copies of chromosome 2. So yeah, that's what will happen there. And that is it for part D. So we'll move on to question 5 then.
Sweet. So for question 5, letter A, we're looking for a triploid cat. And so in the question, it gives us the answer for a 2N, or the 38 total chromosomes is 2N. So what we're going to do is take that divided by 2, which will give us 19. So 19 is N. So 19 times 3 will give us 57 chromosomes, which is the answer. And so for B, a cat that is monosomic for chromosome 12, this will give us 37 chromosomes because chromosome 12 only has 1 chromosome instead of 2. And so for C, a cat that has suffered a terminal deletion on chromosome 7, this will give us still 38 chromosomes because a deletion just means a chunk of it has gone or has broken off and been deleted instead of a whole chromosome. So we go to D, a cat that has suffered a Robinsonian translocation between chromosomes 17 and 18. This will give the cat still 38 chromosomes because one hasn't been added or one hasn't been deleted. It's just still the same number. And so for E, a cat that has suffered a reciprocal translocation between chromosomes 6 and 9. Again, this will still give us the 38 because they just translocated. They weren't deleted or added upon. And that is all for question 5.
All right, we're good.
Good. I hope you have a wonderful weekend.
All right.